Okay, so we are giving educational on 49. Heads up, I might be a little nervous, so I might not be able to explain well. Okay, problem here. You are given two integers, x and k. Grasshopper starts at point 0 on x-axis. In one move, it can jump some integer distance that is not divisible by k to the left or to the right. What is the smallest number of moves it takes? The grasshopper will jump some integer distance that is not divisible by k left or right. Number of moves it takes grasshopper to reach point x. Well, okay, it's is front end of them. Okay, well, it's pretty simple that x is like 1 to 100. So if x is 1, of course, we can just move in one move. So answer will always be 1 or 2. So suppose that we can directly jump, then it will be a multiple. We can directly jump, then this number will not be a multiple of k. We are at 0, right? So, okay, so we can directly jump if x is not a multiple of k. We can easily check this. But if x is a multiple of k, we can take two moves, jump if x is a multiple of k. Okay, then surely x minus 1 will not be a multiple of k, or and neither will be 1 because k is greater than 2. We can like show that I'm doing here minus 1 both sides, then it will be x k minus 1 here instead of like something like that. And k can never be, k is greater than 1, then it will be like always be greater than 0. So we can move in one move. So we can easily do that. So code will look something like this. We will take the integer x and k as input. I think they have also allowed DP because like with these constraints you can even do deep, but we can always reach in two moves. We have already like shown that, so we don't need to do the DP. So this is how it will look like. So we can say that okay, 110, 1 3, and 2 like 9 1 7 3. Everything works. Hmm. We can move. We can open all the problems. Maybe until the right now. Hmm. I want to see if my problem was accepted. You are given a string as of length n, where each character is either less than or greater than. Array A of n plus 1 integers is compatible with string S if for every I 1 to n, Si represents the result of comparing Ai and Ai plus 1. For example, given this array, it is compatible. This. There are other arrays which are compatible with that string. For example, this. Cost of the array is the number of different elements in it. For example, 1 2 5 4 2. If 4, the cost is 4. The cost is 3. Is you have to calculate the minimum cost among all the arrays which are compatible with the given string S. Hmm. Well, here will never be happening. I think something like we want to look at the number of elements such that I'm not equal to my previous one. If I'm not equal to my previous one, I can do minus minus or something like that. Maybe like if I'm something like that, then like these three numbers can be equal to these three numbers. So answer will be one here. Like four here. So I want to look at the largest consecutive days. Okay. And like I am more name costing all this compared with the given string is. There is a number of different elements in it. One like how the fuck is it one here? Uh, this is justified like five elements, number of different elements. Like, for example, the cost of 20 is this. Like AI plus one. Yes, that is important. 37, 30. How is it 2000% all the arrays? It is something else. The first of the answer example the array can be 13, 37, 42, 37, 38. Different elements in it. Isn't this like three? Why did it print two here? Like there is a number of different elements in it. Uh, well, I will just print answer minus one because everything seems to be answer minus one somehow. It's definitely like three elements and they are only printing minimum cost of all arrays which are compatible with the given string as. The first is the array can be this. Like there are like three distinct elements here. They have still printed two. Minimum cost. Number of different elements. For example, uh, don't know man. I think like they are more or less high. Uh, For the last array, like last two elements can be equal. Last two elements can also be equal. Checking for the last part. Hmm, what? Oh, if it is like, I will really be mad because array size was like n plus one, and they are like legit. Every element is decreasing here. It should be six. It doesn't passes, I will be, still be mad. But if it passes, fixed. Okay. Hmm. No. Well, we all know it is gonna be 2 to 5 1. Okay. Less submissions because of the problem was like wrong. Well, they should take care of simple stuff like this most of the time. Uh, Zero one question is call it a pattern. Let's say that the binary string matches the pattern if you replace each character question with zero or one so that the string becomes equal. For example, 0010 matches no 010 doesn't. But 00 doesn't match yeah or yeah. Because the binary string is the minimum number of operations to form arbitrary contiguous substrate of the string required to sort the binary string with minimum. Okay, it's all about like if I put all the zeros in. Okay, so basically it is all about sorting. So when it comes to sorting, we really care about one stuff like hmm, which one of my answer was wrong. First one most likely. Okay, so we mostly care about simple stuff like inversion count. If like, or we can say that the smaller element should be in the front and the larger element should be in the back. Well, modest is itna, so we cannot actually iterate on question marks, but we can keep track of. If I keep for each question mark, if I keep zero here, is it better to keep zero here? Is it better to keep one here? We can always calculate that. If it is better to keep like one here, or whichever it is better to keep, we will keep that and will move in the front. So how to calculate what is better to keep? Okay, so for this, if we want to keep it zero, we will count the number of ones before me, and the we'll count the number of ones before me. So if that is x, and cause that was less than the cost of binary string, the minimum number of operations of the form between contiguous substrings of the string required to sort the. Wait. Oh fuck. So it's not mainly about the inversion count. So what we want is we want to clump things together. So if I am between one and one, then I want these question marks to be one. So yeah, like I thought that sorting in general sorting algorithm will be applied, but no. So suppose this case happens. When I'm between two ones, I want one here. Okay, for this question mark, one or zero, both are like fine. So if there is a question mark in the front, I want it to be zero. Question mark in the back, I want it to be one. Okay. So for this question mark, like I will keep whatever was before me, and I can keep moving like that. So this puts us like if I was between two ones, then I will obviously one because I am putting everything before me. If I was between zero and one, so it doesn't matter whatever I put here because like contiguous, what will happen when we sort 1 0 1 0 type strings? So we will first like reverse this, then we get 0 1 0 1, then we like reverse this part, then we get 0 1 1 0, and we reverse this. So like contiguous reverse happens, or we can just reverse this part. Oh, okay. So we want like things to be as clumped up together as possible. Like ones to be like if there are I want 1 0 1 0 to be as less as possible. 1 1 0 0 is better than 1 0 1 0. And 0 1 0 1 is better than this because I want zero in the front, one in the back. Okay, so we can do that in implementation. Yes. Okay, we are not given actually size. So if f dot front is equals to question mark, as I said, we want the front to be zero because that will be best for us. If it is already one, we can't do anything about it. Listen. And this is working because we are going forward by like SFI Mason will not be question mark because we would have already like taken care of that. Okay, so we are pretty close to their solution. But yeah, in the end, the only thing that matters is the pattern. Like 0 1 0 1. The most of the ones we can just from them together to form a 1 1. So let's see. Well, they might have like some case where it might not be the best pattern, but it should be the best pattern. Hmm, you pretty sad. A regular packet sequence. Okay, it will be in queue for a long time, I think. A regular bracket sequence is a bracket sequence that can be transformed into a correct arithmetic expression. Okay. A bracket sequence is called beautifully one of the following conditions satisfied. It is a regular bracket sequence if one of the following conditions. The order of the brackets in this sequence is reversed, it becomes a regular bracket sequence. For example, this. If we reverse, okay. So either it is regular bracket sequence or its reverse is regular bracket sequence. You are given a bracket, you have color in such a way that every bracket is colored into one color. Every color is one bracket colored in that color. For every color, if you write down the sequence of brackets having that color, order they appear, you will get a beautiful bracket sequence. Minimum number of constraints are recorded is impossible. Okay. So the case where it will be impossible, let's talk about that. Like the trivial case will be if number of opening and closing brackets are not same. So that is that. And suppose something, okay, suppose something like this is happening. Okay, we can do it in two colors. My thought process is like we might be able to do it in either one color or two color. Either it's a regular bracket subsequence, it's an or it's a like normal bracket sub. We can always color it in 2 colors. Okay, so What gets me on this is like we can just pick some brackets and we can just pick there as we are going forward. We can pick some counterparts. Okay. And we can pick some like regular brackets and like suppose I will say there are X regular brackets. Okay. Yeah, I will pick these brackets until the brackets in front of me, until I have like more of these brackets for me. Okay. So if this is a regular bracket subsequence in one of the ways, reverse way or like direct way, then of course it will be best for me. Okay, so we can just do that real quick. So what here idea is that we can answer is always true. So less than or equal to two. So what happens is we can always color in one color if it is a regular bracket subsequence or its reverse is a regular bracket subsequence. This is the simple case for one. For minus one, the case is when there are the like opening brackets are greater than closing opening brackets and closing brackets are not in the same amount. Okay. So when is the answer two? So in this case, like answer will be two because the the bracket sequence is not well balanced. Okay. So what do I mean by not well balanced? Okay. So like basically just it is not a regular bracket subsequence. Then what can I choose? Like how can I choose some bracket subsequence? Okay. So what I will do is I will I can divide this subsequence into two subsequences like this always. Okay. And I know this is a beautiful sequence, this is a beautiful sequence. Okay. So how do I know that I can divide into this? Okay. So if this can be bigger and this can be smaller. Okay. So what I will do is I will keep iterating and I will like this is my first sequence. This is my second sequence. Okay. Then what I will do is I will keep iterating this thing. I will keep iterating this into my first bracket subsequence, brackets like this, and these into my second bracket subsequence until I reach a point that if I put one more of this bracket subsequence here, then one more of this bracket subsequence here, or one more of this bracket subsequence here, I will not have enough closing brackets to make this a good subsequence. And this will then I will keep all the closing brackets in this and all the opening brackets here. And I know for the fact that the closing brackets and opening brackets are in the same amount. So the number of closing brackets here will be same, number of opening brackets here will be same. So I can just do that, and this will be enough for me. So let's do that. Okay, so what I'm just gonna do is 1 - 1. Okay, so good of 0 and equals to count greater than or equal to 0. Good of 0, good of 1 equals to count less than or equal to 0. Okay. So what this means is if one of them will be good, then I have a like beautiful sequence. So if a bracket sequence is regular and its reverse is irregular, when you go from the reverse, and do like prefix some trick on bracket sequences, then it will always be negative. Basically non-positive. Well, I could do that count. Well, if count only, but okay. Out minus backslash and return. So what this does is like, as you can see, like I am adding one when I have opening bracket and minus one when I close bracket. So this should be zero. But if it is not zero, answer is minus one. So what I will do now? Okay. Well, it might be a bit harder than I thought at first. Okay. So I want to just keep track of the number of opening braces I have. Okay. Then okay. First if good of zero or good of one. I equals to zero, I less than plus. Okay. I less than one, I plus zero. Zero. So I will do zero. So how will I pick the curve? So I want to know that if x2 is equals to opening bracket, count L plus plus, L count R plus plus. Okay. If M minus count R is like absolutely greater than count L. See out to opening, then to revise one. Else see out one. Else two. Funny. Somehow I should be here in the start. Oh, Now let's see how good my implementation skill is. Like I could do a like more of a like brute implementation on it, but it would not be as clean. Oh, 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 oh. Like it is passing, so good implementation, I guess. Imagine if it fails now. 16 pretest should be there, I think. More than 16. Interesting. Generally, there are 16 pretests, something like this. 16. Hmm. 8 teams participating. Let's see. Oh, I'm quite slow. Oh, wait. Damn, bro. 8 teams participate in a playoff tournament. The teams are numbered from 1 to 2 की power k in order of decreasing strength. So the team 1 is the strongest one, team 2 is the weakest one. With a smaller number, always defeats the team with a larger number. First of all, teams are arranged in some order during a procedure called seeding, which is assigned a unique value from 1 to 2 power k is called a seed. It's a starting position in the playoff. The tournament consists of 2 k minus 1 games. The teams are split into pairs. Teams with seed 1 play against the teams with seed 2, team with seed 4, so on. The K minus 1 teams, if only one team remains, it is declared the champion. Thus, together K minus 2 teams are played. First one, team with the seed in this order. After that, together K minus 1 teams remain. If only one team remains, it is the champion. Otherwise, together K minus 2 games are played in the seed 1 versus seed 2. First one of them, the winner of the game. Seed 1, seed 2, seed. No. After the tournament, the team are assigned places the tournament phase when they were eliminated. In particular, the winner of the tournament team winner at the finals gets placed to three, and the two teams eliminated for finals get placed four, five, and so on. Blah blah blah. Okay, all teams eliminated in the first by eighth gets placed nine and seven. We established the rules. Do a little rigging. In particular, we want team one with the teams we want to take place one, place two, teams three and four to take place three, and so on. For this example, okay, some seats are already reserved. Rigging the tournament apparently. Okay, we'll do that since that my large. Okay, so the basic functionality here is we want the teams from like I can like do that a little bit. Reading myself. Maybe. Okay, so one will win all the way. We know that for sure, right? So the ones eliminated here, I want them to be the numbers from 1 to 2 की power 1 to 2 की power k minus 1 should be the number that win here. Okay, so if one of them are together in the positions, then there is no way. Then they should win. Okay, and here in this level one, 1 to 2 your k should win. In level 2, 1, 2, 2 की power k minus 2 should win. Okay. So can I do something like divide and conquer in the middle? So I can do something like 1, 2, 3, 4. Okay. So if like there are in this place, 2 should not be in this place. 2 should be here. Okay, 1 is here, 2 is here. Then two of these numbers should be here, and two of these numbers should be here. 3, 4, like 3, 3 and 4 are removed, right? So one of 3 is here, one of 4 is here. 1 is here, 2 is here. Okay. 3 is here, 4 is, one of 3 and 4 is here. One of 1 and 2 are here. Okay. Two of 5, 6 and 7, 8 are here. Okay. So I can do that by the, if I just do a little like minus minus, then I can do that by their highest bit or their log value. Its log is 0. I can say that 1, then their number greater than 2 to the power, the 2 to the power 0, 2 to the power 1, 2k order. Okay, so I can give the number I 2 to the power 3. Okay. So just their larger value, something like that. So half of them should be here, and half of them should be on this side. So 5 and 6 and 1 and 3. So 1 and 3 should be here. Okay. One of 5 and 6 should be here, and two of the larger power should be here. Two of the larger power should be on this side. Okay. If 1 and 3 are not unknown to me, okay, then I can just do something like I don't really care where one of them goes to. Okay, 3 should be in this side. Now 3 is in this side, 5 is here, 6 is here, something like that. I can just assume 5 is here, 6 is here, and 3 and 5 are here. Then 1 and 5, I want to divide them again. Okay, after some time, we reduce the value of log. Like initially, 1 and 2 will be treated the same. Both should be on the opposite sides. So value of log is here 1, and 3, 4, 5, 6 treated the same. Value of log is 2. Then after we divide them, 1, okay, 3, 4 are treated the same. Here, 2, 5, 6 are treated the 6, 7, 8 are treated the same. Okay. So these are 2, 2, then 4, 5, 4, 8. Okay. So I want to reduce the value of log in both the sides. Okay, so here the values with with log that go there are this. I can pick some values and send them here. Then here. Okay. So this does feel like some point like divide and conquer, but well, this doesn't feel like that at the same time. So like it is pretty hard to solve that going down. So my idea was to go down in both sides, like and solve individually. Okay. So and the different approaches and the different idea is that I keep the values of logs. So initially I would keep one as 2 1, 2 as like 4 3, 3 as uh what 4 3 like 3 as like 5 6 7 8 and so on. Let's make them 0 1 2. Okay. Then I will go here and I will add after in the second level, these two will be treated the same because they will be the final participants. Okay, so oh oh okay. I think I'm on to something. Maybe mod is equals to 244 3 3. If you don't remember this mod, don't call yourself CPS. Okay, 244 3 and this. Okay. Okay, is then given as like K. Okay. Um, yeah, this is 19. So 5 and 20 are 5 basically. But Y taker is 2 6 plus 5. So what I want is for 0, And if I, okay, so if it is minus one, we'll continue. Otherwise, we'll take count of I, count of 31 minus underscore including zeros R. Because we are treating 1 and 2 is initially the same, but 1 and 2 are not essentially the same power of 2. So we have to do this. Okay, so divide in B and C and intel comma and R comma and level. Count. Well, I can keep the count of everything in this part myself. Okay. So what will 5 become? 5 will become like okay, so I have 2 and 3. I have 0, 1, 2, 3, and I have 4, 5, 6, 7. Now this looks a lot better because their higher power of 2 is same. Their higher power of 2 will be same. And there will be 0. Okay. I think level should be enough. Okay, so pass this dude. Did I just name it model? Oh, let's see. Now, will it run first? No. And it just said no. बुरा. एटलीस्ट क्या मैं यहाँ तक रन करूँगा? Ah, okay, we ran until here. Now I'm more interested in. We should have called the function now, but 2 comma 4. I'm dumb, bro. I, at least one of them is correct. Shape level is 1. Level 1. 0, 1. Okay, so this should be enough or no, it is not dealer level from exercise. Minus one. The fuck? Level left of 5, 0, minus 1, 0, 1. Interesting here. Interesting stuff. Okay. Oh, that is true. I thought it was this case. Hmm. Damn. Bro, if it works on first try, like this should be this should not at least go there, boy. Yeah, dude. I'm doing nothing with this thing. We are doing this inside. I thought I would go like inside and just divide this into two, but it was better doing it inside only. So we didn't really need that. I think this should be enough. Let's see. Do we pass? Hmm. What the fuck? I want to know that why is it they are both on the equal level. Okay. Here initially left of I is equals to 0. It should be 0 on the top level itself. It was 0 until a couple of minutes ago. Count of left was 0, 0, 0. Going to some What the fuck should be? Yeah, like here it should be like two, two in count. It should be. Why the fuck is it one? I don't understand this. It should be 1, 0. It should be. It should be here. It should be two, two. Oh, when I did that, I also did something with it. Okay, so I was doing I minus minus when I had like previous count loop, but I didn't do it again. Oh, direct test 15. Just show direct AC. Don't even try. Fuck, fuck him, dude. Where the fuck does it even? Bruh, it's not even. Like, just in case. Uh, this should not affect that much. The mod is correct. Why does it like far fetched runtime? Such a fetch. Well, that should not have happened. These elements. E6, but E6 should be enough. I don't know. I think might have just. I legit don't know why the runtime error. But again, yeah, no spike. Okay, so now we have to remove the runtime error. One or max of I minus synchronized speed. Hmm. I will have to like I think stress something out. Like three will be okay. Three out of I think I will do that. It's passing all the tests. That's very interesting. This question 19 is small number. And okay, one thing. So I think I don't know. And it is zero zero. If R is greater than R is greater than zero, then it is zero. It should not be a problem. Just me 66. Even though this is a lot higher than it should be. Modern. I I like feel like somewhere around. I feel like problem will be around here somewhere. Like 31 minus underscore built-in AI. Uh, Zeros, counting zeros AI. There should not be that thing. Like I can just do this. It's like one minus two. Oh, yeah. What the fuck? I am done. Actually, I don't know why everything else fast. Like sad. Like how much? 20 minutes. Accepted. 20 minutes for this bullshit. Damn. Okay. The hmm. It's quite a low submission from the test. Like it was quite easy, even though we took like quite a lot of time and that. So Berlin contest has just finished. Monocarb and polycarb jury are going to conduct an editorial. Unfortunately, the time is limited since they have to finish before the closing ceremony. There are n problems in the contest. The problem are number from 1 to n. The problem takes 8 minutes. Uh, and Polycarp are going to conduct an editorial for exactly key of the problem. The editorial goes as follows. They have a fully this for them in order to remove n minus k problems without changing the order of the make take some prefix of k problem, prosecuting empty one, remaining suffix of them. So then they go to the different problems, but the address of that problems in parallel. So that much time as the longer is to the split the problems and split them in a way that the address misses as early as possible. And the duration of the what the fuck? Why can't we take the lowest k problems? Ah, why can't we take the lowest k problems? I think I have a pretty great idea. If I take the lowest k problems and like Monica get 1 1 1 and he gets like something like 3 2 4 and I could get like here something like 5. Then 1 5 3 2 4 is like 9. But 1 5 1 and 1 2 3 is like 6 and 7, which is better. So yeah, so we can't pick the smallest k always. But we will pick some of the smallest k's and what we are gonna do is we will say okay some prefix I will pick some smallest k, okay, and then I will say okay between now before this number I will pick the smallest number before this number if polycarp has a smaller time and I will pick that number. Okay, so k smallest numbers, but also there can be some numbers that are equal. But will it really matter if we optimize it like that, even if they are equal and I have not taken them? Okay, Ponocar will take this number, his largest number that he had. Then we'll do the same until we have both the numbers. I think this should work. It is something like 2 pointers. First, we will take the case model. Suppose I take 1 1 1 here. Oh, that will give the answer. Uh, some way that it won't give the answer. This we have to pick. Uh, what the fuck? Okay, we have to pick three. So if I 1 5 3 will be the answer, and the answer will be like 6. Okay, 120 315 5 135 again, and the answer will be 5. No, 6 will be 3 4 6 8. Hmm. Like even then, like 1 5 3 2 4 1 1 5. Here. If you take 1 1 4 7 and 5. If I had 4 here, and I had picked like 1 1 1 3 2 4 here like this, then the best answer would have been 1 4 1, which is 6, and 2 3 1, which is also 6. But I would go around 1 1 4 1 4, which will be 7 and 5. So, okay, sum of the smallest x numbers from the left, y numbers from the right set, plus y is equals to k. Seems like a two pointer type thing. Initially, I will take like k smallest numbers and put them all in a set S. And I will take this set S1 and I will maintain two other sets, two other multi-sets basically. So instead of multi-set, okay, two other multi-sets, we have to take multi-sets because of the number. But I'm skeptical about multi-sets because there are same numbers. Like multi-sets have same numbers, but the lower bound will be bad. Like taking lower bound in multi-sets will become useless. I want just the next number of this number. Okay. Like I have some KMs here. I think map will be better instead of multi-set, both for maintaining and like taking values. Hmm. And initially we have taken all the numbers from the back, K numbers, and initially zero numbers on the front. Then I will take the first number and I will say, can this first number be taken in this set? Then the largest number taken in this set will reduce because if I reduce this number, then the sum will total sum will reduce. When total sum is reducing, I can like total sum and total like a max of left sum and right sum is reducing. Maintaining this in two pointers and maps pretty like bad if I will say. Like I don't know a good enough data structure for this, but maps will do the work more likely than not. So what we want to do is two pointers and just maintain the two sets like of all the numbers in both the sets and of all the numbers in the last set only. Like we don't really we do care about in this set also last numbers because we want to take some good numbers in the end. Okay, so we want to take all the numbers in the set left and right. We can easily do that using like maintaining the sets using two pointers, and then I want to take at each position. I will remove some elements in this set, add that element in this set, and maybe remove that element from the better set of this set and add the element present in the set. If there is no element present in the set, I will directly add this element in this set and add extra element from there. Okay. Okay. So there are test cases, of course, and we have n comma k. Okay. Some will be pretty large. Then MB, G, G. So MB will represent second set, MA will represent the first set, G and GB will represent the good first set and the good second set. Okay, so then we will do like this. Okay, okay. Now, okay, I would while count is less than k, add M, G, MB, comma, G, G. So while we are erasing, we will take priority from erasing in MB and then take priority from erasing in GB. Okay, so I want to say this. Now I want to auto adding is all into good, but auto convert. Convert. like this helps me to easily convert in like simple time. Okay, so what I want to do is I want so this will be like these are not MAMP, these are good or good B to not get confused. So what this does is I will take okay no so I will have to give both here and B. Well again I should have not moved that equivalence MB with GB comma MB comma ME comma MB comma MB. Okay, so I will say now I know that sum of A is less than equal to sum of B. Okay, sum B. So where I have to add? Okay, I have to add in sum of A. Okay, so it's MA dot empty return. Okay, so well is equals to MA dot return false. First, if active plus val so active plus val um, A minus val B. Uh, implementing maps like this is like pretty boring, but okay. So true is like yes, I did convert them, and okay, add MB to GB. Okay, MA of your 5 plus plus content comma GA. Is GG of your 5 your 5 while convert comma GA comma MA comma GA comma MD comma survey comma MD. Auto view comma V. Is star M dot begin. Okay. Convert was auto can't be called. Okay. Hmm. 5, 21, 18. Well, I wish I get AC on the first try. Hmm. 2, 6, 5. Hmm. Interesting. Then, interesting. This problems. Oh, 4 minutes. Minutes. If it doesn't get AC, we are not likely gonna get AC. Okay, wrong answer on test two. Something definitely wrong with code. Okay. Huh. Hmm. So I guess we will stop recording here right now. I think I have explained all the problems enough that I solved. So there's no need to go over them again, I guess. Not able to get F. Well, it took 20 minutes extra legit, this problem. Okay. So let's see. Well, you will be able to see my solutions after the contest. Hmm. I think like somewhere around, I am pretty close that I think solution should be somewhere around here only, but I think like there will be something else as well. Like I'm pretty sure like this should be a solution. I am missing something. Maybe I'm like adding something wrong somewhere. Where B plus plus R begin of second minus equals to one. 0 dot second 0 dot equals previous 0 dot end M bit W plus plus second minus. Begin of second then dot begin dot begin. Okay. Mm, like just for the sake of it, let's try like have define it long. I don't think that's the issue, anyways. But who knows? Maybe some miracle happens and I am actually correct. Okay. Yeah, I'm not correct. Okay, so okay, we'll stop